I think I do that every time.
Yes. Hello.
Let's talk about the essential components.
You mean the essential components of a rainwater harvesting system? Yes. Let's go. We're excited. What's in it? You must have a picture, Michelle.
I do have a picture, and starting with number one, the roof.
Well, obviously, the roof is a key component of a rainwater harvesting system because it's the catchment area that catches the rain and then it travels to the roof gutter system, which might be number two on your drawing.
Mhm.
So, and through the downpipes and maybe a leaf diverter. Um,
Oh, but the drawing does show something before the leaf diverter, and that's a little bit more common in cold climates such as ours, which is a three-way valve. Number four, a diversion valve or three-way valve, right?
okay.
Yeah,
Uh,
we tend to use them, say, often if you think about in Canada for sure, we get such cold winters that you don't keep your above grade tanks full of water, and that we would tend to only use the water for irrigating gardens, for instance. So before winter, we drain and empty our tanks, and they can be used to direct water away from the tank in the winter months.
okay. So that doesn't become a block of ice.
Exactly, exactly. So that's where you would see the diversion valve used in a system.
And this would be different if the tank was underground below the freeze line.
Exactly. Frost. If you had a frost protected tank and you were collecting water year round, then you wouldn't need something like that, right?
So number six is um, a leaf diverter. And number seven is a first flush device.
Mm-hmm. Tell us a
Um,
little bit more about leaf diverters. I know they're one of your favorite devices.
People previously had only thought the screens were as good as the ability of the screen to entrap or capture material, but they actually work even beyond that by changing the flow characteristics in the downpipe.
Mm.
So why is it improving biological or microbiological quality? It's because the a lot of microbes attach themselves to sediments and debris. So, so if you take those sediments and debris out, you're also taking the microbial potential microbial contaminants out of the water column. So,
Mm-hmm.
quite an interesting, underestimated process, but very significant results in our national surveys.
Mm.
Then we have a first flush device, which are okay, but I'm not the fan I used to be of first flush devices because in our laboratory work and our field work, we found first flush devices greater than about 10 or 20 litres wastewater but don't improve water quality. And you see these magic formulas that come from nowhere where between roof area and size of first flush devices, there's no science behind them whatsoever.
Mm. We've found them really difficult to maintain, to be honest, and did put first flush devices on all of the first systems we installed. But after reviewing a lot of the research you had kind of thrown my way, I'd say I definitely err towards not using them in designs go forward, especially knowing what I know about the treatment train and all the other ways that all the other design strategies we can employ that I think are a lot more successful with less maintenance.
Well, in my own home, we avoided the first flush device, but we've got good leaf diverters.
Mhm.
And if you have a leaf diverter just before all of your rainwater harvesting pipes, gutters, downpipes into your tank, so you've only got one of them rather than lots of them,
Mhm.
easy to maintain, and they're very effective, potentially more effective than a first flush process.
Mm.
First flush can be good at removing sediments. There's been a range of other claims made about them. we haven't found that in our research.
Yeah,
But
and we've just found that that drainage port, which is number 8 on the diagram, has really tended to get plugged up, and then it's not working at all, right? Like if you're not really on maintenance and making sure that you're taking out the port and letting it drain out, it just ends up getting plugged, and then you end up getting a septic column of, um, you know, not very nice water kind of being potentially pushed into your tank.
and that, and that's a really good point. A good leaf diverter stops debris entering your tank. And what that debris does, even though it might be completely harmless to humans, it'll decompose in your storage and you'll get discolored water and that rotten egg smell. And people go, oh, my rainwater is really contaminated.
Mhm.
But all that's really happened is organic materials has entered it and decomposed. And the benefit of the leaf diverter is it's easy to maintain and it's actually diverting that stuff at the very minimum. The disadvantage of the first flush device, it's usually storing that stuff if you don't maintain it. So ultimately, your first flush device can be actually contaminating your water column that bypasses it. So you know, first flush device is great if you're going to be maintaining it. And if you make it too big, you're not going to harvest any water or no real gain in additional water quality improvement. So things to consider.
Especially when you're saying if you make it too big, especially in areas where you get a lot of light rain, ongoing light rain, right? Because if you live in a climate where your rain is more misty, you're almost flushing that um, away more often, aren't you? Compared to, say, places where you have one-off larger rain events.
So this is a really important point, Michelle. Successful rainwater harvesting systems work because of the small events, not because of the big events. And it's quite a misconception of almost everyone who engages in this space. They think rainwater harvesting is successful because of the big events, and they assume that it can't be successful in places where it only have small events. But because of the efficiency of roof systems, very small events add to your storage. Like 2 or 3 millimeters of rain on your roof will add to your rainwater storage.
Mm.
So roofs don't have big losses. There are some misleading texts around there that try and assume roofs are the same as earth catchments supplying dams,
Mhm.
but they are not. They have very small losses unless
Mm.
there's something horribly wrong. So all those small events actually fill up your storages or partially fill your storages and make rainwater harvesting work. So it's actually not the big events that dominate behaviour of rainwater harvesting. So if you have a system where you're diverting a lot of every event, you may divert all the small events and your rainwater harvesting system just doesn't work very well.
Mm.
And I've seen that often in Australian practice. So we won't be doing that, will we? What's this 9 thing?
It's
What's going
conveyance
on there?
piping. It's conveyance piping.
Yeah.
And in this particular diagram, the tank is right beside the house, so there's not much. It's almost just some piping to get from your leaf diverter into the tank. But conceivably, depending on where you place your tank, you could have longer runs of piping there.
And then you have it going all the way into the bottom of the storage.
Yeah, let's talk about that. I mean, that idea was really driven by this idea of a quiet inlet that I believe one of the first rainwater harvesting practitioner courses that Rob took. They were very much encouraged this idea of quiet inlet, and one way of doing that was to split flow at the bottom. Was that number 11, right? Just to kind of make sure that the water coming into the tank doesn't disturb any sludge, doesn't disturb the water column.
So
So,
we found it's
mhm.
nice to have, but we found the quiet inlet was probably not required.
Hmm. And Rob
The
will be glad to hear that because he had to climb into a tank once before to install a quiet inlet and didn't like that very much.
and they're not very quiet. And it's one of these things where someone's thought of a potential problem and therefore they've come up with a solution. But yeah, it's good that it's on the diagram for completeness, but it's not something I'd encourage. In
Okay,
fact, it can be quite counterproductive. So
right. So how do you, or what has your research shown in terms of one of the best ways to add water into the tank?
just let it flow into the top, because into the top is not disturbing the sludge. The sludge is held together by polysaccharides and a range, which is very, very sticky materials. And rainwater in a downpipe, especially after it's passed through your leaf diverter, does not enter your storage as a jet. It enters at the more laminar, gentle flow than
Right.
people assume.
Would this be another good spot though for like a basket, a basket filter, uh,
There's a
basket
whole
mesh
range of
screen?
providers in Australia who
Mhm.
actually have that entry point into the top of the tank. They have the pipe stops just above the top of the tank.
Mhm.
It passes through a very fine mesh. That's a classic Australian design.
Hmm.
Originally, because of this thinking, people wanted to sell calming devices in Australia, and very quickly became
Calming devices? Oh, for the inlets.
calming. Yeah, but they're not really calming devices because the water column is the calming device, and
Right.
the traditional design is the pipe goes in through a mesh at the top. In fact, one of the providers in Australia who's very successful provides a little round device at the top where the water goes in, spirals around, which actually has a amazing cleaning effect. And by the water just drips out underneath that into the tank. You don't certainly don't need to have one of those. There are lots of things in rainwater harvesting that are nice to have, things that are not essential for
Hmm.
treatment train.
Okay. And the quiet inlet as shown on this diagram is one of those.
So
Yeah.
15.
Where are we? 15. Um, aha. So now we're going on to the intake in terms of where where the water is pulled from your tank. That's the intake. And this particular diagram is showing one of those features that might be nice to have. And I'm really curious your thoughts on this, but it's a floating intake. And the idea with this
We,
particular design is that the ball at the top floats and keeps the intake in the center of the water column. Because, of course, as your water level goes down, your intake would stay about in the center.
so the best quality water in the tank is in the bottom, just above the sludge layer. So
Mm-hmm.
your inlet 16 has got to be above the sludge layer, and that's what we design. There was a whole movement for a while that said, oh, no, we've got to have this intake floating somewhere near the top. So the higher you get in the rainwater storage, the worse the water quality is going to be. So, but that idea came from Germany, and they're very precise. And I remember lots of arguments with their German engineers. I said, well, why would you do that? Oh, no, we've assumed that you want to be nowhere near the sludge at the bottom. We're actually just above the sludge at the bottom, because the sludge is sticky and a very good thing. It cleans the water column. So just above it is the
Right.
best quality water.
So a very simple design would just be to come out of your outlet port and put a 90-degree and then 6 inches of pipe, right? That would lift you up, or maybe even less because your inlet, your elbow is going to
In
have a
Australia,
few
we
inches
say
of it.
100 millimetres above the bottom.
Yeah.
A lot of manufacturers have cribbed a bit, and their inlets are 90 millimetres. So there's no little V pipe. Their pipes just go straight out to the pump. And the classic installation process is no one gets inside of tanks. No one wants to, as
Mm-hmm.
Rob found out. So, and they come with their outlet. However, there are all these things that are nice to have, but I would highlight that absolutely you should absolutely not harvest rainwater from near the surface of the rainwater storage, because that's where the water surface microlayer is.
Mm-hmm.
If there's going to be any contamination in the rainwater system, it would be very sticky to that surface layer, or it'd be drawn down into the sludge at the bottom, but it's bound in the sludge with other materials. On the surface layer, it's not.
What about the design idea of having your inlet water into your tank and your outlet as far away as possible on opposite sides of the tank? Would that be possibly a design strategy that would have greater influence over your water quality than necessarily, you know?
This is what we do in our advice in Australia. So the diagram you're showing on the screen, if you're letting that water in close to the house, it's the opposite side of where the pump is.
Mm-hmm.
And what happens is any buildup of sediment, etc., happens the opposite side to where the pump draws water out. And research for a young chap named Anthony Spinks showed just that simple change in design process dramatically changed the performance of the rainwater harvesting system.
Wow.
So little things make a massive difference. So
and little simple things, which is, I think, one of the big insights and epiphanies I've had over our time on our conversations.
The rainwater industry has attached a lot of technical fixes that people can sell. Like in Australia, the latest trend that is absolutely not needed is tank cleaning companies who'll come and vacuum your tank and often make the water worse. But, it's a nice technical fix. Someone's made a business out of it. So great, nice to have, but gee, be careful with it. So
let's get through the components to that.
25.
25. Okay, so we're following the outlet.
Yes.
There's a number before, 24 and 25. Right. So 24 is an isolation valve. And that's really just a smart design practice for isolating your tank and doing maintenance, right? And 25 is the hose bib.
Okay. And 26?
26, I think, is a pretty important little part. It's just a little strainer before your pump. This is the one that's shown as a Y strainer.
I was hoping you would say there's one of those in there, because it does two things in our rainwater treatment frame, in our anatomy, doesn't it? It protects the pump, but it's also another step in improving the quality of the rainwater.
That's really interesting, because I think I certainly would have put it in as a mechanical engineer to protect the pump, and I would have never considered that it was going to be improving the water quality.
There you go.
So explain, how does it improve the water quality? And why is it part of that treatment train?
Because you've got your fine mesh screen there to make sure particles aren't drawn into your pump, which you as a mechanical engineer will know is protecting the mechanism inside the pump from fatigue and wear. But removing more particles which have attached to them, if they're in the water, in the unlikely event, the microbial particles are actually attached to the sediments. So it's like part of your treatment train. At this point, that's usually a 30 micron filter used to protect pumps, 20 or 30. That's quite a fine filter when you think it through. So you're removing any residual materials before you send the water to anywhere. So and it's good that we picked that up, Michelle, because lots of mechanical engineers in Australia have assumed that all sorts of things will be drawn out through a pump in supply. And I remember pointing out to one of them, well, yeah, that 20 micron filter, which they had in that case, yes, I know that's protecting the pump, but that's also taking sediments out of that bit of the water. Not much can be drawn through that pump.
And I should say that even though this particular diagram shows the filter and the pump on the outside of the tank, there's also really great designs where there's a filter and a submersible pump inside the tank.
Yes. Yes, I think I sent you one of those.
Mm-hmm. Mm-hmm.
We moved at our home from a submersible pump back to an outside
Hmm.
pump. So, we've gone to a very low energy variable speed pump that fit with our house that's off grid and runs on solar energy.
Mm-hmm.
The submerged pumps tend to be a little more energy hungry, and
Hmm.
so something to think about. But I'm sure they're going to improve the design of submerged pumps as well.
Mm-hmm.
Variable
Mm-hmm.
speed pumps are quite important because they only use as much energy as you need for your particular use.
Right.
The garden variety pumps, general pumps have used in rainwater harvesting traditionally have one operating speed. So if you're
On.
flushing on and on going fast using
Mm-hmm.
energy, so if you're flushing the toilet, which is a very low flow, or if you had a low, and I hope you do, you have a sustainable washing machine that had a very low flow and low water volume requirement,
Mm-hmm.
the pumps are still working flat out to supply this very low flow rate because they're
Right.
trying to provide a high flow rate. And that's very energy efficient. So the new variable speed pumps will actually only operate at the demand
Right.
requirement. So if your washing machine needs 4 litres a minute, which a lot of them do, it will provide that
Right.
at a very low energy profile.
Yep.
So our research shows the variable speed pumps in sustainable houses versus a sustainable house with a traditional pump has a massive difference in energy use.
Wow.
So, what about 19? What's that thing, Michelle? What's going on?
19. Well, 17. The water will hit 17 first.
Yes.
And something that I've got drawn on this illustration is I think it's referred to as like a skimmer, right? It's just this idea. Well, it's an overflow inlet, but it's the idea that um, if the pipe is cut at a diagonal, you'll the anything floating at the surface of the water will more easily be able to enter the pipe. So that's what's shown there.
Yep, it's overflowing.
Yeah. Yeah.
And you're sending it via the pipe at 19 to an outlet at 20.
Exactly.
And that outlet better be in a good place, Michelle.
Very, very important and sometimes overlooked, surprisingly, right? In terms of how the overflow water is managed. And bringing it back to this big picture water resiliency, there's quite possibly a lot of water that's overflowing from your tank, especially in our climate where we get really large rain events. Most of us don't have tanks anywhere near enough to store the rain that would come in a rain event. So we're just holding some back. And that overflow water is an absolute valuable resource that can be put to productive use elsewhere on the property, whether ultimately you can think of your soil and as one of your most cost effective water storing strategies.
So I'm glad you mentioned soil
Mhm.
because nature's rainwater harvesting device is actually soil. It doesn't matter how big you make your rainwater storage on your property, lots of rainwater will still bypass your tank unless you live in Arizona with Brad Lancaster, for example.
Mhm.
So if you can divert your overflow to soil profiles and gardens and put that water back in the soil, it's a very beneficial outcome.
Mm-hmm. Mm-hmm. Yeah, and the higher the carbon content of your soil, the more the water holding capacity. And there's a really neat upward spiral that happens when you start taking better care and stewarding and growing biology, right? All these things. You'll be able to store more water, and then you'll be able to grow more plants, and then you'll be able to store more water, and so on and so
I
forth.
think
So,
it's fantastic.
yeah. So that's the
So
overflow piping.
so everywhere from the roof to the soil profile in your garden. Now you have a rainwater harvesting system, yes?
Yeah, you bet. It's all connected. It's all interconnected. Number 28, let's point that one out because it's kind of close by. The foundation.
That's a rather important element, isn't it?
Super important. And it's really easy to underestimate how heavy a tank full of water is.
So 10,000 litres of water is 10 tonnes, more or less.
Mm-hmm. Mm-hmm.
So you need a fairly substantial or well-designed foundation, don't you?
Yeah. What kind of foundations do you commonly see, say, in urban areas in Australia?
My own house sits on a small concrete slab, which is 100 millimeters thick. I put some reinforcing in it. Sorry, I'm a civil engineer, my first profession, and let it cure, and then I put the tank on there. So 100 millimeters thick is not very thick, but it's thick enough to have compression strength, so it'll take the weight on top of it.
Mm-hmm.
In many areas of urban Australia, they just compacted some sand or gravel on the soil and put their tank on top of that.
Mm-hmm.
Sometimes that hasn't gone too well when people hadn't been cognizant of the soil that sits underneath. So you really want a stable base underneath your storage. So you don't necessarily have to have concrete. We had a massive debate with our rainwater harvesting system in Australia that said we're being prohibitive by saying maybe there should be a concrete base under all of these storages. And not many farmers have concrete bases. Some of them have the tanks up on stands, on poles. So you need to be aware that water's heavy, and if you're storing a lot of it, you need to have a stable base underneath.
Yeah, and the stand thing as well, because it is really tempting to want to store your water higher up. There's lots of benefits and advantages to storing water higher in the landscape at higher elevation. You can more easily passively irrigate and move water around. But again, if you're going to be storing water on a stand, you don't want to approach the design of that stand lightly, not understanding what kind of weight it needs to be able to hold.
Yeah, so case in point, on the farmhouse of where I grew up, my father put a 10,000 litre tank 20 metres in the air because he didn't want to turn on the pumps all the time.
Mm-hmm.
It was okay.
Mm-hmm.
But in hindsight, after my training as an engineer, I thought, oh, dear, I hope that was designed properly.
Yeah, it might be smarter at times. Everything's very contextual, but to use a little solar pump to pump water up to higher elevation, in the landscape, and then be able to gravity
We
feed
have
water.
a colleague in Australia who does that. His big rainwater storage is at the very lowest point of his house, his house yard, his property. And he has a small one he lives on the side of a hill, on the top of the hill, so gravity feeds his house. So then he has a very small, low energy pump that gradually tops up his smaller one.
Exactly.
So, flushes his toilets by gravity and washing machine by gravity and so on. So you need to look for those opportunities in the landscape for sure.
Absolutely. Yeah. And all the reason it's really important to build a site plan and to really understand all your elevation changes across your site, right?
You're going to teach people about site plans.
That's coming up, right? Okay, so what numbers have we not hit on this diagram?
What about 23? What is that thing?
23. Well, let me just look in my book. No, that's an air vent. Yeah, that's just the ability to allow air to replace the voidage, basically. As your water level decreases, you want to be able to bring air into the tank, and as it increases, you want to be able to vent air, right?
We don't use air vents in Australia, but
okay.
Because we're letting the water in through 22, which is your
the manway. Yeah. So you're saying that when we talked earlier about that inlet that is just a fine screen mesh, it's often located on the manway. entrance.
Yes,
Right.
and
And that kind of saves the number of ports you need through your tank as well, doesn't it?
absolutely.
Yeah.
And
That's
the
really smart.
pipe 9
Mm-hmm.
just lets the rainwater enter the the manhole. What did you call it? The
Manway, manhole.
manway, manway,
Manhole. I might have said manhole. I think manway's better.
manway, or woman may get in the
Yeah.
tank. So,
So you would just have the conveyance piping come, and then maybe there'd be an elbow, and it would just be dropping directly into that little
uh,
meshed inlet.
yeah,
Right
and
in
the
the middle
mesh
of it.
is
Mm-hmm.
less than 1 millimeter mesh to stop mosquitoes and all sorts of things crawling in. And it's ironically quite a good part of the treatment drain. And
Is,
what
is that
happens when that
Oh,
water
sorry, I was
hits
gonna say,
that
is that the
mesh?
same? Is that the same mesh like on the first flush diverters? Are those usually 1 millimeter meshes as well?
Yes.
Okay,
Yes.
yeah. So sorry, what you're
So
saying? What happens is,
when the water in that downpipe hits that mesh, you actually get more turbulence, and so you're actually the water's being calmed because it's actually passing through that mesh.
Mhm.
So
Right. So that eliminates the need for an air vent. Absolutely. That's
but,
very logical to do it
uh,
that way.
but if your storage is underground
Yeah.
and it's completely sealed,
Yeah.
which we found with bladder storages in Australia,
Hmm.
the because air can't access this completely sealed device, you very quickly get an anaerobic environment, and the the base materials out of the walls of the bladder was being leached into the rainwater storage because of the anaerobic environment. So,
So point
uh,
being, it's really important for those tanks to be able to breathe.
absolutely.
Hmm.
If they're above ground, it's not a problem, but if they're underground, please don't make them fully sealed to air because they'll become anaerobic and
Mm.
things will happen. So then you'll need your air vent 23.
Right. Right. I think we've pretty much covered all of the essential components. Is there anything else you see here, Peter, that you can provide some insight or thoughts or perspective on?
No, I think you've got
Oh, you know what we missed? We
what?
didn't talk about 14 and 13. I mean, we've talked about them in the previous module as we introduced them as key concepts, but let's touch base on those ones again.
Is 14 the biofilm of
It
the wall?
is the
Is
biofilm.
it indeed? You can't buy one of those. Nature provides it, but it's an essential part, isn't it?
Yeah.
And yet, sometimes you can't even see it, but it's there. So it's pretty cool you put that in there, Michelle. It's biological anatomy of the rainwater harvesting system.
Mm-hmm.
So the biofilms are usually the base materials in it are usually soil bacteria
Mm-hmm.
because they're very stable, resistant to everything, and they build other materials around them. Then they develop what's known as polysaccharides, so very sticky materials. Biofilms are known as cities of microbes. And then when they create a critical mass, you still can't see them, but they're a critical mass, then they get hungry. So they start eating materials that pass by,
Mm-hmm.
and big metals, other microbes, you name it, gets drawn into biofilms. So 13 is also a biofilm, but we call it a sludge. Both of those parts of the rainwater harvesting system are extremely beneficial. So we want to look after them.